Hi, my name is Kent Lee and I teach computer science at Luther College. In this series of videos, I'll be talking about data structures and algorithms with Python, which goes along with the text that I've written with my co-author Steve Hubbard. I would highly encourage you to go out and get this textbook and read it along with watching these videos to get the most from these topics. Okay, so in an earlier introductory video, I talked about types and the importance of types for us as programmers. I'd like to demonstrate or talk just a little bit more about that, and then we're going to take a step back and consider something related to types anyway. So I'm going to start up a Python interpreter here just so we can play around with Python just a little bit. And I'll talk about the number 6 here, for example. 6 is an integer in Python, and that's stored in memory as a 110. If I were to actually go out and look at the memory, I would see a 110 in a byte someplace, which represents that 6. This is the powers of 2, so it'd be actually 2 to the first plus 2 to the second, which is 4 plus 2, which is 6. So if I looked in memory, I'd find a byte someplace with a 110 in it. But if I were looking in memory and saw this 110 with 5 other zeros in the same byte, I wouldn't have any way of knowing that that's really a 6 that's in memory. I need to somehow categorize that. I need to give it a type in my Python program, and I give it a type simply by writing the number 6 here. My Python interpreter understands that if I write 6, I mean the integer 6. If I write 6.0, that means the float 6. I can actually see this in my program. If I type the type of 6, I see that it's an int, and if I look at the type of 6.0, I see that it's a float. These numbers are represented different in memory. They are not represented exactly the same. The integer 6 I know would be 110. The 6.0 is going to have a 110 someplace, but there's more information that is also associated with it. These types tell us how things are, the kinds of operations that we can do with these values. Adding two integers together is different than adding a float and an integer together. So the types help us determine which instructions and which operations are defined for them. Okay, so I'd like to take a step back for just a moment and talk about two categories of values, objects and references, that we can use in our programs, that we use in our programs when we write them. I want to go through this information with you because I want you to have a good, solid understanding of what objects and references are before we delve into more detailed topics in algorithms and data structures. So you need to have a good, solid understanding of object-oriented programming, and to start getting a better understanding of it, we're going to talk about objects and references. So when I write x equals 6, I'm actually creating both a reference and an object. 6 is the object, and x is the reference here. So x is the thing that refers to the object 6. So I've got an x, I've got a 6, and I'm going to make x point to the 6 by writing x equals 6 in my program. It's easy to determine what the reference is and what the object is, because if it's on the left-hand side of an equal sign, it's always going to be a reference that we're assigning. On the right-hand side of the equal sign, we might write an object, but what we're really getting is a reference to an object. And so we're taking the reference to the object 6 here and storing it in the reference that's named x. So you can see that I've got a y that's over here as well. If I were to say y equals x, I'm actually going to have two references pointing at the same object. So over in my picture, this is the way things look at this point. So I have both x and y pointing to 6. And it's a little hard to see that they're both pointing at the same object at this point, because the 6 is immutable, which means that I can't change it, so I can't somehow determine that they are really the same object. But we'll see in a moment where we can actually verify that they are pointing at the same object. So if I were to say y equals 6, then I've got a little different situation. It looks like they're still pointing at the same object, but they're not really. They're pointing at two different objects that are both have the 6 value. So writing x equals 6 or y equals 6 makes both x and y point to different objects even though they have the same value. Okay, well, let's say that I make x point to a list. So I can change the reference x at any time I want to, and x is going to point to a list, and so this is my picture at this point. So x is pointing at this list here, and this 6 value that I had here is kind of gone at this point. It kind of goes up in smoke, I guess, is kind of what I'm showing there. What happens with that 6 object is it's collected by what's called the garbage collector, so that space in memory can be reused. So this is the picture that I have at this point. X is now pointing at a list, y is still pointing at that 6 object, and so that's kind of where we're at this point. Now I'm going to make y point to that same list, so just like I did before, y is equal to x. And I'm now going to show you that they really are pointing to the same thing. If I do an x.append, I can append to the list that x has. And so if I append 6 to it, take a look at x, there it is. I've got the 6 in the list. But if I take a look at y, the 6 is in that list as well. So what I did is I appended the 6 to it. And you can kind of see here what's going on is I have one element in this list, and that element in the list is actually a reference that points to an object that is the 6 value. So this is really what happens with a list when you append to it. You're appending a reference to a list, not the actual value, but a reference to it. And I think that you should keep this in mind, that lists are really lists of references to things. Now, I'm not going to follow through on always writing it that way. I'm going to write my objects for a list inside of the list object, but you should be aware that really a list is a list of references. So I'm going to show them this way just because it's less messy and because we'll be able to keep track of things, and also because for integer objects it doesn't really matter because they're immutable anyway. So it's hard to tell the difference between a reference and an immutable object. So I've got 6 in the list. According to the picture, I'm going to append 5, so I could do y.append of 5, and if I take a look at x, x has got 6 and 5 in the list, and so does y. So they really are pointing at the same list here. So x and y are references. These two are actually references as well. But I'm not showing them that way in the picture. Okay, so if I make a separate list, if I want to make a separate list, I can do that in a couple different ways. One way to make a separate list would be to say something like y equals the list of x. And if I do that, now I've made a copy of the two, so I'd have a copy of the two. If I look at y, it's got 6 and 5 in it. If I look at x, it's got 6 and 5 in it. And if I append a 9 to that x list and look at x, I've got 6, 5, and 9 in it. And now when I look at y, I've just got 6 and 5 in it. So you can see I made a copy of the list object by actually writing the type list and passing into it a list that I wanted a copy of in this case. So now I have two references that are pointing to two separate list objects. And if I change one, I am not changing the other at this point. So it's good for us to keep track of the idea of references and objects. Objects are things that we create by either writing a value like 6, so here's an object being created, or we might create it by writing the name of the type of that object and then passing something into it as well. We might change an object by calling a method on it. So I changed the object that X refers to by calling the method append on it in this case. So, but when I write X dot append, I'm not changing the reference, I'm changing the thing that it refers to. So I'm changing the list that X refers to in this case. Okay. So I'm hopeful that you see that there are two different categories of values. Every value in Python is either a reference or an object. References are created and initialized by saying y equals or something equals. If I have something on the left-hand side of an equal sign, it is a reference that I am assigning. And the thing on the right-hand side is generally going to give us some object, and we're going to get a reference back to that object, so it's going to be the reference I get back from creating this list object that is going to be assigned to y in this case to make it point to a new list. Hopefully that helps to clarify that we have these references and objects that we need to keep in mind. And if you can kind of form this picture in your head every time you're looking at assignment statements, this will make other code that you look at much clearer in the future as to what's going on.